Hi students, this is Miss Williams. I am in the lab and I'm going to talk you guys through the lab that we were going to do tonight, but we're dealing with a weather situation. So hopefully grab your lab book. I'm looking at the lab called rates of chemical reactions. It is a clock reaction and we are going to study the kinetics of a reaction. And so basically what was going to happen tonight is that we were going to have 4 different groups. Each group was going to run this reaction with different concentrations, and we were going to time how long it takes the reaction to take place, and from that we would measure a rate of reaction. And then we can use the method of initial rates to write a rate law for this reaction. So if you're looking at page 169 in your book, you can see the reaction that we're going to do. I was going to show the book on the screen, but the camera has it backwards, so just bear with me. On page 169, it shows you the reaction where we're taking the peroxy disulfate ion. We're reacting it with potassium iodide. They don't show the potassium because it's a spectator ion, but that iodide ion is going to get converted into the iodine ion, into the iodine substance. Okay, so it's going from an ion to something with no charge. Well, that's significant because iodine is something that will form a complex with starch that creates a color change. So we are going to add some starch to this reaction, and when the iodine gets to just the right level, we should see a sudden color change. We're going to time how long that takes to take place, and it allows us to measure the rate of the reaction. So they talk through how we're going to be adding sodium thiosulfate, which is something else that's involved in the reaction. Every time we add a test tube of that, and you're gonna, when I start the reaction in a minute, you're gonna see me adding test tubes. That is the thiosulfate ion. That thiosulfate, every time I do that, it is 2 × 10⁻⁴ moles of that ion. So that's it's gonna be interesting because when I add that ion, all right, so back up just a second. When you first start the reaction, you have the iodide ion. It has a charge. The reaction is going to turn that into iodine with no charge. Well, every time I add a test tube, if you flip over to page 170 at the top there, equation 6, they show you how iodine reacts with that ion to turn iodine back into an ion. So what you're going to see is iodine is going to be going back and forth from having a charge to not having a charge, having a charge to not having a charge. When it does not have a charge, when you have iodine, not iodide, but iodine, then it will complex with starch. So we're going to see a bunch of different color changes. Like the color change indicates that enough iodine has formed. We'll add some more stuff, and that sends it back into the ion phase. So the color is going to go away. And then the reaction takes place even more, and the color change comes back. Then we add another test tube, and the color change is going to go away. So that's kind of what to look for. The graph on page 171 shows you how we're going to graph moles of the disulfate ion versus time, and the slope of that line is going to give us the rate of this reaction. Okay? Then we're going to run the reaction with different concentrations and use the method of initial rates to write a rate law. So this very much lines up with what we've been doing in the lectures. Okay? We do not do the preliminary experiments. I would read through the lab on page 171. It has some helpful comments that may explain some of the things about the reaction that you're going to see. But I'm going to flip over to page 172, the kinetics experiment at the top. It talks to you a little bit about what we've done. In class, each group was going to be one of the 4 solutions that is mentioned there. I'm doing solution 3. So what that means is I've gone around the room. I have a flask here. That flask has 50 milliliters of Ki, 1 milliliter of starch, 1 milliliter of Na2S2O3, and then 23 milliliters of potassium nitrate and a drop of EDTA. Okay, so it's got a total volume of 75 milliliters. I also have a beaker, which is here. Okay, let me get my beaker in here. Oh, okay. This is going to be a pain. Okay, I also have a beaker, and in that beaker, I have 50 milliliters of the ammonium solution that you can see there. So that beaker is described in the paragraph down below. So when I mix these things, I'm going to start a timer and the reaction's going to go. Okay. The other thing that I want to tell you that is going on here is I have this set up on a stir bar. So like you can see here, there's a little magnet down inside the solution. And this looks like a hot plate, but it's really a magnetic stirrer. So when I turn that on, it's going to do the stirring for me and just stir the reaction so that I don't have to. Okay, I'm going to try to turn that down so it's not so loud. Okay? But the reaction is not going to start until I mix this test tube and one of those test tubes in that beaker into the flask. At that point, the reaction starts, and the iodide ion that is currently inside this flask is going to start converting into iodine. And we're going to measure the time that it takes for that to happen. Okay, so pretend like you got your stopwatch out. Basically, let's be honest here. I'm not going to sit here and measure times. I'm just going to show you how the reaction works, and I'm going to send you some data that has the times in it. Okay, so you're probably not going to see me taking times, but that's what you would be doing. Okay, so here we go. Reaction's about to start. I'm going to mix everything together. So I've got my stir rod going. I would mix this in. Okay, we get a color change. I'm going to add one of these. Colors should go away. I start my timer. Now I'm going to keep my timer going until I see another color change. When I see another color change, I'm going to add one of these test tubes to it. So each test tube has, I'm going to look at my data here. Each test tube has 2 × 10⁻⁴ moles of the persulfate ion. Okay, so every time I add that, I'm adding that number of moles, and we're measuring how long it takes that number of moles to react. Okay, so I'm going through now and showing you how we get the data, and then I'm going to pause the video and switch over to screen mode and show you how to analyze the data in a few minutes. Right now, I'm waiting for, there's my color change. Okay, so now I add another test tube. All right, so what that, and we just wait, we started the timer over again. And so what that means, at that point, there was enough iodine without a charge in the solution. Then I added that other test tube that took it back to iodine with the charge. Okay, so we're going back and forth. When the iodine does not have a charge, when it's in a neutral form, it complexes with starch to give us a color. And you've probably seen that in your biology classes before. There's a lot of labs where they use iodine as a color change to indicate for starch. Okay, I'm gonna go ahead and get my other test tube ready. Okay. But we would basically sit here and do this for 7 test tubes. Okay, and we're gonna graph the data. Okay, so in a few minutes, I'm gonna show you how to graph the data. I'm only gonna do a couple more on the film, and then we'll jump into what to do with the data. But now sometimes this color change is like a dark blue or a black, and sometimes it's more of a yellow color. And it really just kind of depends on the nature of your starch, whether or not your starch started to degrade some. In this case, today we've been getting more of a yellow color, but that's okay. It still works very well as a clock reaction. I'm just waiting for the color change. We'll show it to you one more time. There's the color change. Okay, so it turned colors. I would pour in this and start the timer again. Okay, so we measure the time between the color changes. So now I'm going to pause the video and I'm going to switch over to Excel and show you how to analyze the data.